Okay, all right. So today what we're going to do is this. We are going to. So yesterday I titled the lesson "Basic Exponential Functions." So today what I'm going to do then is we're kind of taking the step to do the questions that the regions actually expect you to do. So why don't I call that intermediate exponential functions? And let's spend 2 days there. Okay. So let's see what that looks like, and let's get started. Okay. So now let's take a look. So one of the things I want to show you then, right? So this is what we did yesterday, right? We were using this equation, right? And it actually had evolved from this, right? So imagine this is like evolution, right? So the equation evolved from this to this, and today to this. All right. Now you might look at this and say, "Wow, like there's a lot going on there." There actually isn't. So let me show you why. So here, this is the equation from yesterday. All right. Now, technically, same equation, but it's become more refined. What do I mean by that? Now, one of the first things I want you to notice is the similarities and differences between the two equations. So look at this. All right. Again, anytime I switch markers, it takes like forever. So, for example, let me show you this. Right? The a is still a. Right? The exponent right here, still x. Nothing changed, right? So what's the only thing that changed? Yeah, the b, right? Which is the multiplicative, the multiply, right? So again, a, right? A is the initial value. B is the multiplier, and x is the number of times. So that hasn't changed, right? So a and x doesn't change. B just went from 1 plus r, went from b to 1 plus r. So what gives, right? Why? Well, look at this. Here, b is the multiplier, right? So in other words, what we've been dealing with is double, right? And we really only dealt with double, but we can have triple, so on and so forth. But as I alluded to yesterday, the real world doesn't really work like that. Like you don't only, like if you bring money to a bank, they don't only offer you choices to, like, I mean, this sounds silly, but they don't offer you choices to double and triple your money. Like no one does that, right? Ever, right? You wish, right? So what made this more refined is that instead of just saying double, triple, we're saying, hey, look, let's have a little more nuance here. And we're going to use the letter R to represent rate. So hence, this is why I wrote this down here. All right, let me use a magic pen then. Right? This is why I wrote this. It's the rate of growth or decay. So in other words, right, where this used to be just a whole number, now we're dealing with decimals. That's all. Okay, again, right? So if you're adding something, by the way, I actually simplified this equation a little bit because this could technically be a minus, right? So if something is growing, right? So let's say it could be anything. So let's say you're bringing your money to the bank, and they give you interest, and the interest was I don't know, 5%, right? Then you would just add 1 to that. So it would be 1 plus 0.05, 1.05. And that's the, okay, something is about to happen. Oh, no? Okay. Oh, I knew it. All right. So here it will be 1.05 instead. So hold on. I got a visitor. Hold on. All right. Okay. I got to be honest with you. I partially forgot. No, I completely forgot where I was before person came into my room. Okay, so having said that, so therefore, right, now, something can actually also decay. So some of you might be wondering, hey, like, in what instances do I actually have to subtract, right? Do I still have my magic marker? Nice. In what instances do I subtract the rate, right? So, okay, let's say you buy a car, right? I don't know if you guys know the saying or the common parlance or the common knowledge, right? Once you buy a new car, the moment you get into the car and you start driving, the value of that car automatically goes down. Like there's no way you can keep the value of a brand new car, right? So sometimes, right, and you'll see problems later on today or tomorrow that let's say it's at a depreciation, okay? So you guys know what the word appreciation means. So depreciate. So it, you know, maybe a car depreciates 10% a year. Well, that would be an instance where you subtract instead of add, okay? So now, without further ado, let's take a look at some examples so that you guys can get a better look, all right? So let's see. All right, good. So I think we can do these 3 questions a day today, and I think we could do the rest tomorrow. All right, hold on, let me press pause real quick, check it out. Okay, yeah, all right, let's try these 3 first. Do I have 3? Yeah, let's try these 3 first, all right? Let's see how we do here. All right, okay, so now I like to usually put the formula right at the top. All right, so f of x is a and then 1. Now, again, it could be add or subtract, all right? And then with x, hold on. So, okay, knowing that, let's try these questions, okay? All right, now, here, a $24,000 car. Now, oh man, perfect timing. Depreciates, right? So it's going down at a rate of 10% per year. Okay, so what does that mean, right? So, okay, I got f of x equal to, now, let's break these down parts. Let's break these parts down, okay? All right, I can barely speak right now. All right, so look, now, we're looking for 3 things. So one of the things, you know, you guys are probably used to it, is in any of these questions, right, at least for this topic, we're always looking for 3 things. And it's your job to find those 3 things inside this, okay? So look, we got A, right? We got R, and we got X. Now, let's see. So here, now here, these questions, they want you to write the equation. They don't want the actual value at the end of a certain year because they never told us the number of years, but let's give it a try. So now, 24,000, right? That's the price right now. So that's the initial amount. So there's our A. So I'm gonna write that in. Okay, and then here, I got 1, right? That doesn't change. Plus minus. Now it depreciates, so we're not gonna add, certainly, right? So wow, how'd that happen? All right, so we're gonna do 1, right? Depreciates at 10%, right? So there's our R, which is 0.1, right? Like this, X. So let's write this out nice and neat. So here we got 24,000, 0.9 X. All right, and there's our equation, okay? And that's it, okay? Now, in my experience, so let me rewrite this, okay? So that it just looks proper. I just gotta say, in my experience, with these kind of questions, you really get 2 types of questions so far, okay? Based on what we learned so far. One is they just want you to write out the equation like this, right? And that makes sense because we don't have X. Like X is like a missing variable right now, and there's nothing we can do about it, okay? So we're stuck here. Now, let's say the question changes, right? Per year, erase that, for 5 years, right? So that means you bought your $24,000 car, right? It keeps depreciating at 10% every year for 5 years. So if that was the case, then you would do this, all right? And I just want to show this to you. You would just put the 5 there, and then you do 0.9 to the 5th power times 24,000, whatever that is, that will be your answer. Okay, but so far these questions doesn't require that of us. All right, so now let's move on then. All right, let's try the next one. So a stock is valued at $300. All right, so by the way, again, the equation's up there, right? $300. Now what is that? Is that A, R, or X? Yeah, A, right? That's right now, right? Especially with stock prices, right? It's always about what's right now. So right now it's 300. decreases, right? That's good to know, right? Because now we got to subtract by 9%, right? So there's our rate, the letter R, right? Per year. So again, they're gonna leave us hanging with the X. They're not gonna tell us what X is. So that's fine. All right. So right, A, which is 300, 1, right? Decrease by 9%. That's 0.09 per year. Just like that. Now, some regions questions, if it's, especially if it's multiple choice, right? They could leave it like this, but for our sake, just because we know what 1 minus 0.09 is, we can just write it out like such. All right, so keep it nice, neat, and complete. Okay, and that's how we write it. One last one, and then we'll call it a day. All right, you buy a used car for $9,000. Let's see, hold on. You buy a used car for $9,000, so that's the original amount. The car depreciates 9%, so there's our rate. And then after, nice, look at that, right? Now we got our X. Okay, so let's rewrite that. F of X, so A is 9,000. Let's see, depreciate, so 1 minus, oh, it's the same amount, 9%, so 0.09. And now we finally know how many years this is supposed to go on, right? So let's keep going. 9,000, that's 0.91 to the 10th power. Now let me go to my calculator. Let's see, 0.91. Now, one of the things I also want to tell you, I think this is a good time to tell you, that remember, all right, let me use a different color, that when you take something that's less than 1, like 0.8, right, and you multiply it repeatedly, like so, the number is going to be quite tiny. So let me show you just for effects. Yeah, 0.512, right? So that's why it's a decay, because the more times you repeat it. So imagine if you're like, I don't know what's a good example. Imagine if it's like a laundromat, right? Like a washing machine, right? The more times you spin this wheel, right? 10 times you spin the wheel, this number is just gonna get really, really small, really, really quick, okay? So let's take a look. 0.91 to the 10th power, right? Yeah, I got some huge number. Now, let me just tell you this right now. I'm gonna write the number out. By the way, I'm also using a TI-34 calculator, all right? Because it's right here. So now that said, right? What I'm trying to say is this: if you see a number like this, don't start rounding here yet. Don't round this. Don't arbitrarily round this, and then try to multiply the 9,000 afterwards. Take this number, multiply by the 9,000. All right, because it's going to be a more accurate number because you're leaving the rounding till the end. Okay, so I'm going to take that big number, multiply by 9,000, and I got 35. Oh, let me see. I'm trying to round to the nearest cent. So I got 3504.75. Okay, and there we have it. So after all those years, after 10 years, that's what your car is worth. All right, 3,500. So like I said, right, remember what I said about the car depreciating. Okay, all right, so let me press pause. Let me double check to see if there's anything I need to cover, and then I'll be right back. Okay, so one last thing. So I actually went online and looked up depreciation value for cars, because like these things are actually fairly set in stone. Excluding the condition of the car, you know, over the course of the 10 years. But what I want to say is the 9% is actually very low for depreciation. Like I think what would you consider a medium depreciation is actually around 15%. So that's kind of crazy. So there you go. All right. So I think the story, the moral of the story, of that question is, try not to buy brand new cars, because the moment you drive it out of the lot, like, you lose a ton of money. Okay, so let's end this here. Tomorrow, let's practice and solidify everything that we've learned for the past 2 days. And okay, all right, so I will talk to you tomorrow. All right, have a good day. Bye-bye.
OMG, that was so good.